All right, students. So, most of the class requested for 2014 question number 1. So that's the problem that I'm going to go over. So here it talks about grass clippings. They're placed in a bin where they decompose. For the time 0 to 30, the amount of grass clippings remaining in the bin is modeled by this expression here, where A of t is measured in pounds and t is measured in days. Okay, now since this is question number 1, then typically those are calculator questions. So you're allowed to use a calculator on this. Okay, all right, so part A, it says find the average rate of change of A of t over the interval 0 to 30. Indicate the units of measure. Okay, so keyword average rate of change. So when I see average rate of change, I go, okay, let me think back to my flashcard. That is f of b minus f of a all over b minus a. That's the average rate of change, and that's for the time interval or whatever interval of a to b. So how would I transfer that to this problem? I would say, okay, well, my function is a of t, so it's going to be a of 30 minus a of 0 all over 30 minus 0. Because that's my interval, 0 to 30. Okay, and so now I'm going to put this in the calculator and evaluate that. So, all right, what is it? 6.687, 0.931 raised to the 30th. Okay, enter. That is going to be 0.7829. Okay, minus, now when I put in 0, that means I'm going to be putting 0 in for t, which means that part is going to go to 1, which means that this is going to be, you don't need a calculator for that, divided by 30. So let's see what I have. So I'm going to take that minus, and then divide by negative 0.1968. Okay, so now I have an answer. Let me just reread the question. Find the average rate of change of this. I did. Indicate the units of measure. Okay, so I need to indicate the units of measure. So, here we go. The numerator is A of t, and A of t is measured in pounds. So, and the denominator is t, which is measured in days. All right, so then my average rate of change is this, which makes sense because since it's decomposing, it should be decreasing in pounds per day, right? And it's decreasing because it's negative. All right, so now we have part B. Find the value of A prime of 15. Okay. Using correct units, interpret the meaning of the value in the context of the problem. Okay, now there are 2 ways to find A prime of 15. There's a long way, which I will show you first. Oh, sorry, that's supposed to be t. Finding the derivative. Okay, so the derivative of this, well, this is a coefficient, so it's going to be 6.687 times, and then I'm going to do my derivative of a to the x, which is a to the x natural log of a. So in this situation, it's 0.931t natural log of 0.931. So again, derivative of a to the x with respect to x is equal to a to the x natural log a. So my a is 0.931 and my t is my x, okay? And so now when I evaluate this at 15, I will put 15 into that, 6.687, 0.931, 15, natural log of 0.931. And so let me do that. What was it? Okay. my decimal in the wrong spot. I knew it was supposed to be a negative because I'm taking natural log of a value that is less than 1. And natural log of anything less than 1 would then be a negative. So that is negative 0.16359. Okay, so it says using correct units, interpret the meaning of the value in the context of the problem. So what is the meaning of this? Well, first off, I know that this is going to be pounds per day. So what's happening with this? That means that the amount of grass clippings is decreasing 0.16359 pounds per day. Okay? At day 15. Yeah. Okay, so you used your calculator here, but how else could you use your calculator? I already put this into my graphing portion. I put it in my Y1. And now I need to change my viewing window so that I have at least 15. So I'm going to go to 20. Okay. All right. I'm going to turn on my derivative. All right. So now for the Casios, you can just put in 15. Okay, and so then you can find the derivative right at the graph. Okay, so you don't actually need to work this all out. You could just put it in your graphing calculator. Okay, so on the AP test for this year, most of the problems do not require a graphing calculator, but you can have it on hand. So in case you want to speed things up and not have to find the derivative, you could do that. Okay, so in any case, there is the derivative at 15. It's negative 0.163, which is basically what we have right there. Okay? Same thing. All right, part C. Find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the time interval this. Okay, so the average amount of grass clippings. So this is not a rate, it's an actual amount of grass clippings. So it's not anything having to do, the value that you want to find in the end is not going to be measured in pounds per day. It's going to be measured in pounds. Okay, so the average amount of grass clippings on this time interval, if you remember average value, it's 1 over b minus a integral a to b of f of t or f of x, it doesn't matter, dt. So in this situation, it would be 1 over b minus a, which would be 30, from a to b, 0 to 30, of a of t dt, like so. Okay, and so now you can stick this in your calculator so you don't have to go find the antiderivative of this. So it's going to be 6.687 parentheses 0.931 raised to the x, comma 0, comma 30. Okay, and so that's just the integral. Then I'm going to divide by 30, and so that's what I get. So this is equal to 2.7526 pounds of grass. That's the average amount. Okay, and so now let me read the problem again. Find the time for which the amount of grass clippings in the bin is equal to this. Okay, so now they want me to find the time. Okay, so then that means A of t is equal to 2.7526. So when is A of t equal to that? So this is when I use my graphing calculator and I say, okay, well, here is the function and I want it to be equal to this amount, 2.7, oh, okay. Okay, well, I'm going to do it like that. Let me put that back in. Okay, so what I'm going to do is I'm going to have a graph of the function, and then I'm going to have a graph of a horizontal line. And I want to make sure that I'm only looking at the interval that they're talking about, okay? So I'm going to do my viewing window, and I'm going to say 0 to 30. And the reason why I want to do that is because if I don't, I might have more points of intersection, extra answers in there that I don't need, okay? If my interval is different than the one that they're talking about. Okay, and so there's my point of intersection, right there. So I'm going to find out where that is. I do my point of intersection, and that is at 12.414. Okay, so t is equal to 12.414, actually 4149, so 5 days. Okay, so what you do is you find the average value. So this is the average amount of grass, and set it equal to the equation. Okay, so the work that you would need to show is this equation, and you would show that that function is equal to this value, and then you put it in the calculator and you find the solution. All right. All right, the last problem. For t greater than 30, L of t, the linear approximation to A at t equal to 30, is a better model for the amount of grass clippings remaining in the bin. Okay. Use L of t to predict the time at which there will be 0.5 pounds of grass. Okay. Remaining in the bin. Show your work that leads you. Okay. So this is talking about for time greater than 30. It says to use a linear approximation model. Okay, so let's think about linear approximation. F of A plus F prime of A x minus A. That was our linear approximation formula. So they're talking about when time is equal to 30. So how would I transfer this? I would say, well, A of t is approximately, is approximately L of t, which is equal to, because they want us to name this, A of 30. So it's going to be A of 30 plus A prime of 30, and I'm running out of room, t minus 30. That is our linear approximation formula. This one right there. Okay, so now we want to find out what that is. Okay, so let's see. L of t is equal to A of 30. I'll steal that from up here. So that is going to be 0.7829 plus A prime of 30, which I don't know. So I'm going to go and figure that out from here. So oh, wrong one. Okay. So I had to make sure that I was on this function right here so that I can evaluate the derivative. And so here's the derivative. It is negative 0.055. So it's going to be negative 0.055 t minus 30. So this is my linear approximation line right here. That's my formula. Okay, and now I forgot the question. So hold on one second. All right, so I figured out my linear approximation is a better model for this. Use this to predict the time at which there will be half a pound of grass. Okay, so I want to predict when this is going to happen. So I'm going to use, and I'm going to say 0.5 is equal to 0.7829 t minus 3. And I'm going to solve for t. I can put that in and set it equal to this, but I might as well, I don't know if I should solve by hand. Oh, well, I will. Okay, so menu. All right, so I have 0.5 minus 0.7829 is going to be negative 0.2829 is equal to negative 0.055 t minus 30. Okay, then I'm going to divide by this. I'm going to divide by negative 0.055. Okay, so I have 5.1436 is equal to t minus 30. So I'm going to add 30 plus 30. And so I'm going to get t is equal to 35.14. Sorry, you couldn't see that. 1436 days. And you said show your work, and so I showed my work, and that looks like it's it. There you go. Okay, hopefully that helps. Thank you.